Okay, what we're going to do today is find zeros of polynomial functions. What I've got here is number 40 on page 336. Of course, this is a polynomial function, and I'm looking for the zeros of it. What I'm going to do is I'm going to use some tips that I learned in class just to try to break it down first, get an idea of what I'm looking for, how many zeros am I going to have, are they real zeros or are they not. So the first thing I do is I use Descartes' rule of signs, which says if I take f of x, I look for the number of sign changes, and that's going to give me positive real zeros. So I have a positive x cubed, a positive 12x, a positive 21x, and a positive 10. So I have no change in sign of f of x, which means I have no positive real zeros. So now what I'm going to do is I'm going to take f of negative x and see how many sign changes I have there. That's going to tell me how many negative real zeros I have. So if I take negative x cubed, that gives me a negative x cubed out here, so that's fine. See, if I have a 12 negative x squared, well, that's the same thing as 12 positive x squared, so I'm going to have a plus there, and that's going to turn into a minus 21x, and that's going to stay a plus 10. So I have a sign change here. I go from negative to positive, that's 1. I have a sign change here. I go from positive to negative, that's 2. And I have a sign change here, that's 3. So what Descartes' rule of signs tells us is I have either 3 or 1 negative real roots, because f of negative x has 3 sign changes. So when I find my roots, I'm going to make sure that what René Descartes told me was right, that I've either got 3 or 1 that are negative. Okay. The next little trick that I'm going to use that I learned in class is I'm going to see if 1 or negative 1 are zeros to this polynomial. So what I'm going to do, the test to see if 1 is a root of the polynomial, I'm just going to add up the coefficients to all of these. That gives me 1 and 12 is 13 and 21 is 34, 44, that doesn't add up to 0. If they added up to 0, then I would have 1 is a real root of this. But René Descartes told me I didn't have any positive ones, so of course 1 is not going to work. Now to find if negative 1 works, what I do is I change the sign on all of the odd degree terms. X cubed is an odd degree term, so I'm going to change the sign to that coefficient and make it a negative 1. X squared is an even degree, so I'm going to keep that as a positive 12. X is an odd degree, that's x to the 1, which is an odd number, so I'm going to switch that to a negative 21. And then 10 is a 0 degree, which is not odd, so I'm going to keep that as a positive 10. That gives me minus 1 plus 12 minus 21 plus 10. That does equal 0. So that means I have negative 1 is a real root to this. So I'm going to take that knowledge and then I'm going to synthetically divide and see what I have as a product of factors. So if I put a negative 1 up in here, what I'm going to get in my synthetic division, I drop all these coefficients down. So the coefficient of x cubed is 1, coefficient of x squared is positive 12, coefficient of x is 21, and I got a 10 over here as well. Okay? I'm going to drop that 1 straight down, and I get 1. That turns into a minus 1. Turns into an 11. That turns into a minus 11. Excuse me, 10. That gives me a minus 10 and 0. So sure enough, I have no remainder, which is just proof again of what I found out, that negative 1 is in fact a real 0. And these are the coefficients of my leftover term. So as a product of factors, I have x plus 1. Remember, this is an x minus a minus 1, so that gives me x plus 1. And now out here I have an x squared, because I'm reducing my degree by 1 in my division here. So I have an x squared plus 11x plus 10. So this is the product that I have now. And I can see that this divides pretty easily, so then I have x plus 1, this becomes x plus 10 times x plus 1, right? If I multiply these two together, I get x squared plus 10x plus 11x plus 10, right? Looks good. Okay, so now I've got 3 linear factors, which give me my zeros, right? These zeros are easy to determine now. I have a 0 of negative 1 and negative 10, and that's it, right? Those are the only things that make this 0. So, piece of cake. Now I've found my zeros. Let's go back and do a check with what René Descartes told me. He said I was going to have either 3 or 1 negative real zeros. Now right here I've only got 2. But what you want to watch out for every time you use the rule of sign is that when you have a zero of multiplicity other than 1, you have to count it as many times as it appears. So my negative 1 zero has a multiplicity of 2, so I have to count it twice. So according to Descartes, my zeros are negative 1, negative 10, and I have another negative 1 out here. So yes, in fact, I do have 3 negative real zeros. So that's how I find my zeros. That's all I need to do. Piece of cake.